I've made it a host.
Awesome.
Okay. Okay. Basically, one thing I needed to bear in mind is the code implementation of these data structures. All right.
Mm-hmm.
There had been so many persons who had actually written codes about how to implement all these data structures. When we get to those points, when we write them, we may end up writing most of the times all those implementations that persons or people had actually looked at. I know in the IT world that like when it comes to writing of code, a whole lot of developers copy codes that had been written
Yes.
without making reference without making references to the authors of the code. And by that you find out that it becomes actually difficult to know who actually wrote or implemented the code, the first
Right.
person. All right.
Mm-hmm.
Because I know in the academic world, whatsoever knowledge that does not belong to you should be referenced.
Right.
So I needed to make these clarifications so that when we get to those points, even though we may have to refactor some codes or tweak it, so to say, but
Mm-hmm.
whichever way, so that you understand that this implementation isn't my personal um code that I actually wrote. Having said that, um today I want us to look at arrays. Basically, I know that you know what an array is in JavaScript. Like you have a variable that can store multiple values. Okay.
Right.
Unlike a language in a language like Java,
Mm-hmm.
which you must specify the type, the data type, and you must stick to that. For in JavaScript, you can store different or multiple data types. Like you can store a number, you can store a string, you can store booleans, you can store even functions and
Mm-hmm.
arrays and other objects as items in array in no other form, but an array can contain all these data types without strictly restricting you to a particular data type, unlike in a language like Java. Okay.
Right.
But basically, okay, let me just move over screen. Oh,
Okay.
oops. I
Let
can't
me.
share my screen.
Yeah. Let me make you. Yeah. I'll make you host again. One second. Let's see.
It
Make
said
host.
holds the enable participant.
There you go. You're a host now.
Okay, okay, okay. Looking at oh, let me come in 1 second. Let me open my editor.
Okay. Put my phone on the charger real quick.
Okay, no, I was actually trying to. Hello,
Yep. I'm here.
can we guys?
Screen sharing. Okay.
Okay,
Good.
hello.
Yep. I'm here. So I can see your
Okay,
VS Code screen.
okay. Oops, I opened it multiple places. Okay, oops. I'm Sorry, I mistakenly closed it.
No worries.
Okay. All right. Okay. Sorry, it's taking a little more longer.
Oh yeah, no problem.
Okay. Okay. Of course, you know the various ways of declaring an array.
Yeah.
Okay. This is our array. And we know that there are so many methods. Okay. So many inbuilt methods. Okay, before we get to that, when you actually look at an array, you will find out that objects or items in an array are stored in a continuous fashion, or those in computer science, what they would call it, are stored in memory spaces in such a way that they can be indexed. Like you can access any of the item by doing whatsoever um array name with the square bracket indicating the index of that particular value that you want to access, right?
Right.
Good. So by that means you can be able to access that particular value. Once an array has been declared, it's actually being stored in memory space in what they refer to as a contiguous way. A contiguous way of storing an array in memory simply means that they are stored or arranged in such a way that a particular um immediately after a particular value, you will get the next value. So it's like they are queued up in such a way that, hello.
Yep, I'm here.
Okay. Okay, so they are queued up in such a way that you can be able to easily access them, because the device or our devices actually allocate some specific memory location that are always next to each other. Like in counting, you have one after one, you get two after two, you get three after three, in such sequence. That's why you arrays are indexed. Okay,
Gotcha.
that can make it possible for any developer or anybody to be able to access um whatsoever item he wants to access in the memory location of the array. But definitely, whenever you are learning a programming language, the tutor may not go into details to tell you how arrays are definitely stored. And also, you know of a statistically typed language like Java, and you know in Java you need to manage your memory space, right?
Yep.
And the, the same is not applicable in JavaScript. In JavaScript is the under the hood, the just-in-time compiler interpreter helps the user to actually do memory allocation and management and all that. But in Java, you have to do that by yourself. So by implication, there are two types of arrays. You have the static arrays and you have the dynamic arrays. Like in Java, once you've declared an array and you've given it a memory space, let's say you've given it a memory space of 5, you cannot be able to add some more items to that array. But unlike in JavaScript, you can be able to add some more, as much as you can, items, right?
Right.
Okay, good. So since that is that you can be able to do that in an array, trying to get back the whiteboard so I can do some little drawing. Funny.
Okay, no problem. Yeah, you're the host. Oh, there it is.
Okay, it's still overlapping. Funny. Okay, now if you have like the array that I declared, okay, if this is a memory space in your device, we had 5 items in that array. The system could maybe this memory space is these two blocks of memory space, okay, possibly could have been occupied by some other things. And the system allocates 1, 2, 3, 4, 5 to store the array. All right.
Okay.
Okay. 2, 3. Of course, this is not the clear representation of the exact way um, computers actually store what's it called, data, because they are being stored in as numbers in binaries, right?
Right.
But it's
Yeah.
just good. Like you go down to bits, and 8 bits make up 1 byte and all that and all that and the rest of them. At the end of the day, you have 32 bytes because it allocates 4 spaces of um bits, sorry, bytes, of which each of the 4 allocations has 8 bits. Okay, so when you convert this number to binary, you have such a representation. But now, for example, in a language like JavaScript, where you have dynamic arrays, where you can still add, let's say, like 7, like 10, 11, because you can be able to use some kind of methods to do that.
Gotcha.
Okay, like you have the push method, you have the push push method where you can actually add more items at the ending part or the ending side of the array, and um you have the shift method, unshift, sorry, unshift method, which can also add items at the last as the first part of the array. So you notice that at different points or at different locations, you can actually add items depending on exactly what you want to do.
Right.
Good. So that's how JavaScript arrays are actually dynamic, unlike static arrays in Java.
Yeah.
Okay, good. Now, when you actually look at arrays in JavaScript, you will also notice that irrespective of those different methods, you can actually use arrays to do so much more. Like in an application, you can even use an array to build some other data structures. That's why I want us to start with arrays. And you can also, on your own, be able to implement or write codes that will represent the making of arrays. But let's also go back to our big O. I need to show you something.
Okay.
Okay. Now, of all those different um, operations that can be done in any data structure, if you check very well, you see you have access, okay?
Mm-hmm.
You have search, you have insertion, and you have deletion. These are the operations that can actually be done on any of the data structures. Now, I've initially talked about access. That's when you want to get a particular okay, let me go back to my
Okay.
VS Code. For example, I can do array index of 3, which will give me 4, right?
Right.
This system is slow. Okay.
No worries. Yep. Cool.
Okay. And you know that okay, I can go through the array by using any of the for loop methods like this as array one.
Right.
I can just tell it okay. Now looking at that chat sheet or cheat sheet, that big O cheat sheet, it talks about access. All right.
Yeah.
And remember, I told you that yes, there is the best case, although it wasn't actually captured here. There is average case and there is worst case,
Mm-hmm.
okay, of the big O on each of the operations on any of the data structures. When you actually look at this, this has to do with assessing an item. Here, you notice that you notice that it's only one operation.
Right.
Okay, only one operation that can be done. Even though I don't know if I made mention of this, when you are talking about data structures and algorithm, you are actually looking at when you have very big number of values. Okay, let's say like 1 million and above.
Mm-hmm.
Even if you have up to 1 billion items in this arrays that has been declared, as long as you know the index or the position of the item you need to access, okay,
Mm-hmm.
once you actually call this, it's only one operation that will be done in order for it to give you that particular value. That's why when you go back here to the big O cheat sheet, you find out that both the worst case and the average case of access on arrays is just but O of one. That's linear time.
Right.
Good. So as long as this access will be done, irrespective of the volume of the data you have on your hand, it's going to be very, very fast. Okay? When you record a graph, you find out that O of one, that's constant time,
Mm-hmm.
it's actually the best.
Right.
Okay. Then the second tool that we have is search. All right.
Okay.
To search through an array simply means that you are going to look through it. All right.
Right.
Like, I hope it's my VS Code that is on showing on your screen, right?
Yep. Yep. It's showing.
Okay. This is of one. Now, in this case, in case where you need to do some searching, all right? Let's take,
Mm-hmm.
for example, you don't actually know the exact index of the item that you need in the array and you need to access it. The best method to go by is to search through it. Is it not true?
Correct.
Good. And for you to search through it, let's say okay, we have in the worst case, okay, you are looking at 5.
Right.
That's the number you want to actually search. It simply means for you to get it, you have to look through from index 0, that's 1, till the last index. That means that the loop has to run check if at index 0 the value is equal to 5. No,
Right.
it moves over to index 1. Is the value at index 1 equal to 5? No, it keeps on going keeps on going. If we have up to 1 million items stored in this array, it keeps on moving through it one after the other. Remember the way I told you that arrays are stored under the hood. They are stored next to each other.
Mhm.
So it has to go from index 0, it checks just in that order until it gets to the last item. Now, in this case now, the access of, sorry, the search method is going to give you the number of um the items in the arrays. Okay, so it's going to be O of n. And of course, from our cheat sheet, big O cheat sheet, you find out that big O at O of n, okay, that's at linear time, is not, in as much as it's fair, but is not too fast or is not too good an
Gotcha.
operation to be carried out, because there are still other values of big O that are better than O of n. You have O of log n and you have O of 1, which is at constant time, which is the best. All right.
Right.
So you find out that the same thing will happen for both the average case and the worst case. So when it comes to searching through an item, an array is not the best data structure, because when you look at stack, okay, sorry, when you look at hash table, you look at the search, both, okay, the search method at its average case is O of 1.
Mhm.
Is that true? So,
Yep. Looking at it now.
okay,
Yeah.
so you now find out that search method, search method using hash table or data structure is better than array data structure on each search operation. There
Yep.
are still other data structures like the binary search tree is O of log n, which is better than O of n. So you find out that's why the search operation on arrays, they are not the best case that you can ever get. All right.
Mhm.
The next other operation you have is insertion. Okay. Hello.
Yep. Yep. I hear you.
Okay. Okay. You know of this method splice.
Yep.
Slice method, it takes three values, right? The first value tells you the index of where you want to execute the operation. Okay, let me use A, B, and C. A, then B tells tells you, or is actually indicating if you actually want to um delete any item, and the last, which could be an object, told if you want to insert the item or delete whatsoever thing you want to do, it's actually going to do that for you. You actually use the splice method to actually insert data or items into an array. Like, for
Mm.
example, we have our array and we access to splice, let's say at index 1. That's where we want to add a value. We don't want to delete anything, but we
Mhm.
want to add, let's say, 2045. All right.
Mhm.
When we actually check at our array, it has added, right?
Mm-hmm.
Good. But the issue now is there was no for loop that happened. Okay. There was no
Mm-hmm.
for loop that happened in this operation. But how come on the big O, can you go to your big O cheat sheet?
Yeah.
Okay. You notice that inserting an item gives you or happens at O of n.
Right.
Is that correct?
Yes.
Good. So why is that so?
Hmm.
Somebody may ask.
I
Now
think I
the
think I know why.
you said
You want me to guess it? I think I might know why.
okay.
Because it'll have to basically wherever you insert something, you'll have to like kind of do a for loop to shift everything to the right, to move everything to the right. Hopefully that makes sense.
That's the that's the answer.
Okay.
Yeah. Because since we are inserting at index one, that means two that was at index one has to shift.
Mm-hmm.
Okay. Now at the end of the day, three will shift, four will also shift, five will also shift, and till the last item on the array.
Mm-hmm.
And when that has actually happened, you now find out that despite the fact that no for loop was actually implemented, but due to the shifting of the items on those indexes, it has actually resulted to an operation occurring at the rate of the number of items of the array. The number of
Mm-hmm.
items, sorry, are those indexes of that particular array. So that's why the insertion operation of an array will run at O of n
Gotcha.
instead of at O of 1, because one item, or okay, or two items, okay, let's just make it one item. Okay, like in this case, because one item was just inserted.
Right.
All right. Okay. Now the same concept applies to deletion. All right.
Mm-hmm.
When you want to delete, the same concept, like you can also use the splice method to implement deletion, right?
Right.
Okay, I don't want to add any item. I want to delete one. All right.
Mm-hmm.
Okay, sorry. At the index of, let me say, 3, I want to delete one item and I don't want to add anything. Okay.
Okay.
So if this runs, you notice that 3 has been deleted. Sorry, I shouldn't have added the 0.
Gotcha.
3 has been deleted, right?
Mm-hmm.
Good. So it also will run at 4 of n because of the shifting of all those values as a result of one one of the items has actually been deleted. So the other ones need to adjust in order to not allow any empty space exists between two blocks of memories. At the end of the day, either they shift to the right or they shift to the left. Okay.
Gotcha.
Yeah. So that's the basic reason why all these operations run at this particular um complexities.
Yes.
All right. Okay. Space complexity. we've been talking about, somehow we've been modeling up time complexity and space complexity.
Mhm.
But basically, all these ones I've been talking about is space complexity. But when you talk about time complexity, when you compare, oh, sorry, when you actually look at the number of operations that would be done, they will be done at the rate of the number of items that you have. Like, for example, the deletion, okay, the search, deletion, and inserting any item in an array will have to happen at the rate of the number of items you have in that array because of the shifting issue that we've just agreed on. Okay,
Right.
good. So that's just that for big O. Now we can basically look at, if I want to build an array, let's say, for example, you went for an interview and you have been asked to implement an array data structure. Can you do that?
An array data structure.
Yeah.
Yes, probably not from scratch, but um, so yes, like let A equal and then the brackets.
Mhm. Okay, what I mean is, can you write a code, for example, and let's say, can you write a function that has methods that will insert values that can be able to access without
Nope.
using the normal array that okay, there are three ways that basically you actually declare an array. Like, for example, okay, let me use const. Oh, my bad. Const array is equal to new array, right?
Hmm.
So then you give it like the number of memory spaces you want, right?
Right.
Then you have another one. You can just declare it like this,
Right.
okay? And you start going by this index of 0. You start assigning, let's just say, name or wherever,
Okay.
okay? You have another easier means. You just fill it up like, okay,
Right.
good. So this is just the traditional way of declaring and assigning values to array,
Okay.
right? Okay, good. Like, for example, okay, for convention,
Mm.
naming convention. Now, there are basic things you have in an array, okay? Every array must contain data, right?
Right.
Or values. Then every array must have length.
Hmm.
Even an empty array has a length of 0.
What was that?
Okay. I said, and even an empty array has a length of 0.
Gotcha.
Good. So now, because this is actually in a class, you can now say, let's say this is an empty array, okay, that we have, and the length of our array is actually 0 at this particular time. I need you
Hmm.
to understand something. Whenever you want to build any data structure from scratch, all right,
Hmm.
you can use either an array or you can use an object. to store
Okay.
your value. Okay, so depending on whichever method that it's actually convenient for you. Okay, we know
Okay.
that every array has a push method, right?
Mm-hmm.
And the push method will actually like insert a value or an item into the array, right?
Mm-hmm.
And in order to do that, sorry, my bad. In order to do that in an array, what you actually basically need to do is first of all, you have to grab this dot data. Okay,
Mm-hmm.
here, here. When you grab it, you assign a length to it. Remember?
Mm-hmm.
Then the next other thing is because an item has been added to it, you increase the length. Our empty array here has a length of 0.
Mm-hmm.
Okay. Then
Yeah.
once you are inserting any item, it means that um it simply means that the length is going to increase by 1, right?
Right. Get my phone really quick. Sorry. I have to leave in a second to get the kids from school, but maybe we could do like 5 more minutes for now.
Ooh. Is 1 hour yet already?
Oh, okay. Yeah, let's go ahead and if we could just do 5 more minutes so y'all can understand this part, and then I'll run and go get them.
Okay. Now let's instantiate the array by saying new array is equal to date. All right.
Right.
And if we do new array, let's push in any number 3. Okay. My array data.
Oh, the bracket.
Let's push another one. I hope you saw the correction I just made. I
Yep.
made a mistake. I declared it with curly brackets instead of with
Square.
square bracket. Yeah.
Mm-hmm.
Let's push another one.
Okay.
Okay. You can see it, right?
Yep.
Good. You keep pushing in as much as you so wish or you so want. Let's see. Okay, let's do a name. Let's use Harry. Oh, sorry.
Mm-hmm.
Okay. It keeps going on. And you notice the length keeps increasing. All right.
Right.
Good. So that's because every array must have items, the number of items it contains, either 0 or 2, any number
Mm-hmm.
of items, and each of the item that is being added increases the length. All right.
Mm-hmm.
So that is basically how it goes.
Okay.
Yeah.
Well, awesome. I appreciate it. You want to hop on tomorrow and continue?
No problem. Sorry for the delay I had
No
this
problem.
evening. Okay, I'll try to make it as I'll try to start at the exact time tomorrow. I'll try to attend to things I need to attend to. So
Okay.
yeah,
Okay, cool. All right. Well, sounds good. I appreciate it. I'm gonna go run and get the kids.
no problem.
Okay. Thank you very much.
You're welcome.
Okay.
So by tomorrow we'll just continue.
Yeah. Okay. Sounds good.
Okay.
Okay. All right. Bye.